In this video, I will explain the relations among trig ratios, limits to the values of trig ratios, how are trig ratios same for similar triangles, when are the trig ratios negative or positive, and trig ratios of associated angles of a given angle. In my previous video, I have explained how are trig ratios generated. So, if you want to get a complete or full concept of trigonometry, you must go step by step. Sin, cos, tan are the three basic ratios with their reverse, cosec, sec and cot. And as hypotenuse is always greater than the opposite and adjacent, the value of sin and cos always lie between -1 and +1. It means that the values of sin and cos can never be more than 1 or less than -1. But tan and cot can have any value. And the reverse cosec and sec. Cosec and sec either greater or equals to 1. It is the Pythagorean theorem which provides us with the basic trig formulas. When all the terms in the equation are divided by ab square, we get 1 equals to cos square plus sin square. On dividing the equation by ac square, we get sec square equals to 1 plus tan square. These formulas relate trig ratios to one another. All these formulas a student needs to remember as they are used frequently. Now I am going to discuss with you the concept of similar triangles. The concept of similar triangles in trigonometry is very important. Let ABC is a right angle triangle with a given angle theta. D is a point on AB. I would like to drop a perpendicular DE on AC. We get a right angle triangle ADE with the common angle theta. Now F is a point on AC and I drop a perpendicular from F on AB. We get another right angle triangle AFG. But I want one more triangle. I have taken another point on AC, that is M. From M, I drop a perpendicular on AB and we get our third right angle triangle AMN with the same common angle theta. Of all these four triangles, two angles are common, the right angle and the theta. By the triangle property, the sum of all the angles of a triangle equals to 180 degree. So the unknown angle must be x. The angles of all these four triangles are same, the theta, right angle and angle x. So we can say all these four triangles are similar, though they are different in their size and shape. Trig ratios are always same for similar triangles. The next that we need to know very well is the sign convention of trig ratios. X and y axis intersects each other at point O and divides a circle into four quadrants. We know that the x-axis to the right is positive and to the left it is negative. The up y-axis is positive and the down y-axis is negative. A ray of the same size of the radius, when rotates, touching the circumference, it makes an angle theta at the center. We can measure the magnitude of the angle using trigonometry. The point B, as it touches the circumference, it has two coordinates. One is its abscissa, that is along the x-axis, and its ordinate, that is along the y-axis. If we get the value of x and y, then using trig ratios we can measure the magnitude of the angle theta. Now I'd like to drop a perpendicular from point P on x-axis. So we get a right angle triangle OPM. For angle theta, OM is the base or adjacent and PM is the height or opposite. Now using any trig ratios, we can calculate the magnitude of theta. Tan theta equals to opposite upon base, that is PM upon OM. Sin theta equals to opposite upon hypotenuse, that is PM upon OP, and cos theta equals to OM upon OP. As x and y both are positive in the first quadrant, that's why tan, sin and cos with their reciprocals all are positive in the first quadrant. Now the point P has come in the second quadrant. In the second quadrant, x is negative but y is positive. So tan theta equals to y upon minus x. So tan theta and its reciprocal cot is negative in the second quadrant. But sin theta equals to y upon OP, that is PM upon OP. OP is always positive because it is the sum of two square number. So sin theta and its reciprocal cosec are positive in the second quadrant. But cos theta is minus x upon OP. So cos theta and its reciprocal sec are negative in the second quadrant. So cos and tan with their reciprocals are negative in the second quadrant. Only the sin and its reciprocal cosec are positive in the second quadrant. Now the point P has come in the third quadrant. In the third quadrant, for angle theta, OM is the adjacent, OM to the left x-axis, that's why it is negative, and PM down y-axis, it is also negative. So tan theta equals to minus PM opposite upon adjacent. As both are negative, that's why tan theta is positive in the third quadrant. As tan theta is positive, so its reciprocal cot theta is also positive in third quadrant. But sin theta equals to minus PM upon OP. OP is also in third quadrant, but as OP is the sum of two square number, that's why OP is positive. So sin theta with its reciprocal cosec theta are negative in the third quadrant. And cos theta equals to minus OM upon OP. So cos theta is also negative. So in the third quadrant, sin theta its reciprocal cosec and cos theta its reciprocal sec both are negative. Only the tan theta with its reciprocal cot theta are positive in the third quadrant. In fourth quadrant, for angle theta, OM is the adjacent. This time OM is to the right of the x-axis, so it is positive. But PM is down to the y-axis, so it is negative. So tan theta equals to PM upon OM, so minus y upon x. So tan theta is negative in the fourth quadrant. As tan theta is negative, so cot theta is also negative in the fourth quadrant. But sin theta equals to minus PM upon OP. So sin theta is also negative. As sin theta is negative, so cosec theta is also negative in the fourth quadrant. But cos theta this time positive because OM is to the right of the x-axis, so it is positive. So cos theta with its reciprocal sec both are positive in the fourth quadrant. So in the first quadrant, all the trig ratios are positive. In the second quadrant, only sine and cosec are positive and rest of the trig ratios are negative. In the third quadrant, only the tan and cot are positive and the rest of the trig ratios are negative. In the fourth quadrant, only the cos and sec are positive and the rest of the trig ratios are negative. This is the sign convention of trig ratios. Trig ratios of associated angles of a given angle. The x and y axis intersect each other at point O. A ray aligns with the x-axis. When it rotates to the anticlockwise direction, it makes an angle theta. When the same ray rotates to the clockwise direction, it makes an angle minus theta, because we know when rotation is anticlockwise, then the angle is positive, and when the rotation is clockwise, then the angle is negative. Now I would like to take a point on the ray of positive theta, that is A. I would like to drop a perpendicular from point A on the x-axis. The perpendicular touches the x-axis at point M. So we have got a triangle OAM. Now I would like to produce this AM up to the ray of negative theta. The produced AM touches the ray of the negative theta at point B. So we have got another right angle triangle, that is OBM. Both these triangles have a common base, that is OM. Now let's find out what are the similarities these two triangles have. As these rays are the same at two opposite directions, so OA equals to OB, and by construction AM equals to BM, and both these triangles are right angle triangles. So we can say triangle OM and triangle OBM both are congruent to each other. So theta equals to minus theta. Now the sine ratio of theta equals to AM upon OA, and the sine ratio of minus theta equals to minus BM upon OB. BM is negative this time because BM is on the down y-axis, that is negative. But AM equals to BM. So we can replace BM by AM. So the sine ratio of minus theta equals to minus AM upon OA. Hence, sine minus theta equals to minus sine theta. Now the two triangles have changed their direction. Theta has gone to the second quadrant and minus theta has gone to the third quadrant. So the cos ratio of theta equals to OM upon OA. OM is negative here because it is the left x-axis, and cos minus theta equals to OM upon OB, and OA equals to OB. So we can replace OB by OA. So we can write that cos minus theta equals to cos theta. Now the tan ratio of theta equals to AM upon OM. But I would like to multiply a minus sign to both the numerators. So minus tan theta equals to minus AM upon minus OM. So these two minus signs are cancelling out. So we can write this one as AM upon OM. Now for tan minus theta, minus BM upon OM. So both the negative signs are cancelling out each other. So it becomes BM upon OM. But AM equals to BM. So we can write AM upon OM. Hence, tan minus theta equals to minus tan theta. We can measure an angle in two methods. One is sexagesimal method and the other one is circular method. In sexagesimal method, an angle is measured in degree and the smaller units are minute and second. When we divide 1 degree angle into equal 60 parts, then one very tiny part of that angle is called 1 minute angle. And when we divide 1 minute angle again into equal 60 parts, then one very tiny part of that angle is called 1 second angle. In circular method, an angle is measured in radian. But I think you are little confused of radian. I have explained in this video angles, the degrees and radian in detail. So if you see this video, then your concept of degree and radian will be crystal clear. But still, I want to explain radian in brief. In this xy plane, I have drawn a circle. Let's assume the radius of this circle is 1 centimeter, and I want to cut an arc on the circumference of 1 centimeter. So this red line segment is 1 centimeter, and I want to adjust this red line segment on the circumference as an arc. So MN arc is of 1 centimeter that I have adjusted on the circumference, and this arc obtained an angle at the center. Now I would like to measure this angle in radian. But how? When we divide the arc length by the radius, then we can get the magnitude of the angle in radian. Symbolically, it is represented as small c in superscript form. Here, for this angle, the arc length is 1 centimeter and the radius is 1 centimeter. So when we divide, we get the magnitude of this angle is 1 radian. And 1 radian equals to 57.27 degree. So I hope you understand how we can measure an angle in radian. And we can easily relate radian and degree to each other by remembering this formula that 1 radian equals to 57.27 degree. Trigonometric ratios of standard angles. In the table, standard angles are given in degrees and in radian column-wise, and all the trig ratios are given row-wise. You have to learn the values of different trig ratios for all the standard angles very well. If you learn these values very well, you can easily solve any trig problem. In my next video, I am going to explain associated angles of 90 degree plus minus theta and 80 degree plus minus theta. So, keep watching.